Okay, thank you very much for joining. So today we've come to our second tutorial of our data and database system unit. So what we covered in our previous tutorial, we looked into data itself. We described the different type of categories of data types, data structure, and so on. And we looked into the concept as well. And in today's session, we will now focus more on databases design. So we're going to explain the types of databases, describe different relationship types with primary keys, foreign keys, and so on. Then we will also look into explaining normalization and functional dependencies within databases. And lastly, from the mandatory unit learning outcome, will describe databases administration, including integrity and security control. And we also have a merit distinction where we're going to assess the integrity constraints within our relational model. So let's get into our presentation. So today's session, we're going to understand in database design. So what do we refer by database design? This is simply going to refer to the several stages which are going to be including requirement analysis, conceptual design, logical design, and physical design of our database. So we all know that we have different type of databases, which could be SQL, that follows a structured query language, or non-SQL, which does not follow a structured query language. So in our previous session, we made example of non-SQL, which are databases which are going to include files such as images, video, and much more additional data, which makes our database unstructured. So the key concept in our database design, obviously we're going to look at requirement analysis. So we need to understand the data requirements from our end user perspective, and activities. So we have to have the ability of gathering useful and detailed information from our stakeholders. And the outcome of this has to be a comprehensive requirement document that outlines what our database should achieve. Also, we have conceptual design. So what does our conceptual design have to do? This has to create a high-level model of data requirement without considering how the data will be physically implemented. So with the use of softwares, for example, draw.io, we can now create, we can now design them, and we can now create our entity relationship diagram, where we'll find our primary key and we'll have our entities and our attributes. And we have to have the outcome of this is that we now having a ER diagram and a conceptual schema, which has to be a visual schema, a visual representation of how our database works. Logical design. So this, the purpose of having a logical design is to translate the conceptual design into a logical structure. which can now be implemented into our database. So what are the activities that will be involved in our logical design? We're now going to be normalizing data to eliminate redundancy, defining tables, fields, keys, and relationship. So normalization is a very important aspect when it comes to looking into our logical design, because it allows us to, again, reduce redundancy and break our database into smaller database which are more easy readable. Physical design, we're now going to convert the logical design into a physical structure that will be stored in our database. This is where we're now going to create our schema, and we're now going to be storing data from our customers. So database design concept, again, we know that our logical database will have entities and attributes. So what are entities? Entities are objects or things in the database that are distinguished from other objects. So for example, we're going to include customer, product, or order. So we creating this visual schema, and we'll assign it a name. So that is going to be our entity. And our entity will now have some attributes. So attributes are simply characteristics or properties of our entities. So for example, this might now have attributes such as name, address, or email of our entity. Also, when it comes to creating our database, there are types. So by types, we could have one-to-one relationship, one-to-many relationship, or many-to-many relationship. So the purpose of this is to define how entities interact with each other. So how these are connected and they work together. So each of our entity has a primary key. So a primary key is a unique identifier for a table that ensures that each record is unique. For example, one table could be assigned as customer ID, and that's our primary key. So inside this, we now have attributes. We now have all the attributes such as name, last name, address, email, home address, email address, or even card details. Foreign keys, which are an attribute that create a link between two tables. So it is a primary key in one table that appears in another table to establish the relationship. Normalization, again. So the benefit of having normalization is, if we take, for example, Amazon can now have one massive table, because loads of fields can repeat. So in order to avoid that these fields are going to repeat and create a very messy, confusing database, we now have to normalize it. So we have to break it into smaller table to reduce the redundancy and improve our data integrity. So there are various forms. There are one normal form, two normal form, and three normal form, etc., which guide the process of structuring our database to minimize redundancy. Indexing, the purpose of having indexing is to speed up data retrieval operation. Data integrity, where entity integrity referential integrity and domain integrity. So the purpose is to ensure the accuracy and consistency of data within the database. And here we have a summary of what we just covered. So now we're going to explain different type of databases. So let's just take, for example, our SQL databases without covering the non-SQL. When it comes to SQL databases, there are various type of database. This could be network database, relational database, and so on. So these are designed to store, manage, and retrieve data efficiently. But in our case, we will now focus on relational databases. So, as I said, flat databases are the simplest form of database. So they store data in a single table, typically in a plain text file or spreadsheet format. Relational database are now going to store data in table with rows and columns. They use structured query language, SQL, for defining and manipulating data. Non-SQL databases, these are now designed to handle large volume of unstructured or semi-structured data. So as an example, Facebook, social media, works with non-SQL database because there are loads of unstructured data that is generated on a daily basis. So now we'll look into SQL and a non-SQL approach. So the choice between SQL and non-SQL database depend on the specific needs of the application. So with the SQL or SQL databases, this is ideal for structured data and complex queries, while our non-SQL, they will now excel in handling large scale of unstructured data. Here's the summary of what we just covered so far. Our learning outcome 2, we're now going to describe the different relationship type, such as join type and type of key. So we're now going to describe the various type of database relationship. So we'll now look into what is a join and key along with the implication. So before we mention type, so one-to-many is basically a single record in one table that can relate to multiple records in another table. For example, customer ID table can now relate to shipping, shipping table, billing table, or cart, or your basket. So that could be one-to-many. So what are the implications? This is most common type of relationship, and it now helps organizing data hierarchically. Many-to-many, this we now have multiple records in one table that can be related to multiple records in other table. So what are the implications for this? This relation type usually requires a junction table or associative table. One-to-one, this is simply a single record in one table which is related to a single record in another table. What could be the implication for this? This relationship can be less common and is typically used to split data into different tables for security, performance, or organizational resources. So what is an inner joint? So this allows to retrieve records that have matching values in both tables. So whenever they need to link one table with another one, we're now going to use our inner joint. So it is useful for selecting only the related record that we need from our table. So here's the SQL command that we'll now use for us to retrieve the record that we need. So outer joint, there are different types of outer joint. We have left outer joint, right outer joint, and full outer joint. Again, all of them have the purpose of retrieving records. So with our left outer joint, we're now retrieving records from the left table and match the record from the right table. With the right outer joint, will be now vice versa, where we're now retrieving record from our right table and then match it with the record from our left table. And the full join is going to retrieve all records when there is a match in either left or right table. Primary keys, again, we mentioned custom ID, for example, is our primary key. So as definition says, a unique identifier of our table record. This must contain a unique value and cannot contain a null value. So the implication that we could have is that this ensures that each record in the table is unique and can be referenced by foreign keys. Foreign keys, we explained before, which is a field in one table that unique identifies a row of other table or the same table. Compound keys, what do we need a compound key? This now consists of two or more attributes that uniquely identify a record in a table. Here's our summary of what we've covered so far, relating our types of relationship, joints such as inner joint, left outer joint, right outer joint, full joint, and our keys with our primary key, foreign key, and compound key. Learning outcome 3, we're now going to explain normalization and functional dependencies within our database. So again, as we said, the purpose of normalization is to break our table into smaller table, which allows us to easily access our records in a faster and much more organized way. So by definition, functional dependency is a relationship that exists when one attribute uniquely determines another attribute within our database schema. So for example, if we have attribute A, that is now going to determine attribute B. So we say B is functionally dependent on A, denoted as A less than B. Schema normalization. So schema normalization is the process of organizing the attributes in tables of relational database to minimize redundancy and dependency. So the main object in our schema is going to be divide larger tables into smaller related tables and link them using our relationship. Okay, so we now have an normalized form. So we have an example for our unnormalized form. And what we see here is that the data is stored in a single table without any structure or organization. So this form often contains repeating group and redundant data. So if we do not apply normalization, this is what we would get. First normal form. So this is now going to contain only indivisible value, and each column contains a value of a single type. Second normal form. This table now, if it is in first normal form and all non-key attributes are fully functionally dependent on the primary key. So what is it going to do? It's going to remove partial dependencies, and is going to ensure that no non-key attribute is dependent on the part of the compositive primary key. So here are the various examples. Thirdly, we have third normal form. So a table in a third normal form, if it is in second normal form and all the attributes are functionally dependent only on the primary key. So again, we're now breaking into another smaller group. So now it's going to remove transitive dependencies to ensure that non-key attribute is dependent on another non-key attribute. Here are example of them. Here, now we can now look into the summary of what we've looked into on our normal form, first normal form, second normal form, and third normal form. Now we're going to describe database administration, including integrity and security control. So we all know that we have database developers, which is a very high demand job. And with the database administration, we're going to look into integrity and security control, where with database administration, we're now going to look into a wide range of tasks to ensure the efficiency, reliability, and security are operating on our database. So some of the key concepts of our database administration, ACID principles, where these are a set of priorities that guarantee that database transactions are processed reliably. So A stands for atomicity. With this, we're going to ensure that transaction in the it is now treated as a single indivisible unit. So we're now going to validate that. We're now simply going to perform a validation process where we're ensuring that these values are not possible. It's not possible to duplicate them. Consistency. We're now ensuring that a transaction brings the database from one valid state to another, maintaining database invariance. Isolation. We're now going to ensure that transactions are executed in isolation from one to another. Durability. With this durability, we're going to ensure that once a transaction has been committed, it remains so, even in the event of a system failure. So what are the tasks that have to be conducted on our database administration? We have to be maintaining data integrity. So we're ensuring that our values do not alterate, or there's no any such data breaches. So we have to have the ability to have validation, where we have regular validation checks to ensure that the data conforms to the predefined rules and standards. Security control, again, we have to make sure that our data is encrypted. We have a backup and recovery system, and also a auditing where we can monitor activities across our database. Now on our merit activity, we're now going to assess the integrity constraints within our relational models. So what do we mean? We're now looking into integrity constraints, which are rules that ensures the accuracy and consistency of data within a relational database. So our constraints are now going to be essential for maintaining our data quality and enforcing relationship between the tables. What are the key attributes? We're now going to look into referential integrity. So with this, we're now going to ensure that all relationship between the tables remain consistent. Specifically, this ensures that a foreign key in one table correctly refers to a primary key in another table. Domain integrity. With this, we're now going to ensuring that all values in our column falls within a different domain, which means that all these specified rules for them are now going to be allowable data type, format, and ranges. Entity integrity, again, we're now going to ensure that each table has a primary key and that the values of our primary key are now unique and they are not equal to null. Foreign key integrity, pretty much similar concept to our primary key. We're now going to ensure that our foreign key values always refer to existing valid primary key values in our reference table. And here we have a summary of what we've covered so far. So now we have come to a concept which is very important. What is a database schema? So a database schema is basically the logical blueprint or structure of our database. So that is going to define how data is organized, are managed among our database. So a schema is now going to include table, fields, relationship, views, index, and other elements. So the key concept of our schema are tables, fields, columns, record rows, relationship, indexing, viewing, and constraints. With a database administrative, we now have the role of we all have to know that the role of a database administrator is now responsible for installing, configuring, managing, and maintaining our database management system. So what are the key and responsibilities when it comes to installation and configuration? So the skills that are required for this job is knowledge of database management system software, hardware configuration, and operating systems. What are going to be the duties? The duties are installing and configuring database software and setting up necessary hardware and network configurations. Database design, which requires understanding the database design principles and data modeling. The duties are going to be designing database schemas, tables, indexes, and the relationship to optimize performance and storage efficiency. Performance monitoring and tuning. So expertise in performance and tuning are now going to query optimization and system resource management. Security management. The skills required for this are going to have to be highly knowledgeable of security best practice, access control mechanisms, and encryption techniques. Backup and recovery. Skills required are going to be proficiency in backup and recovery tools and procedures. Data integrity and quality. They now have to have familiarity within data validation and integrity constraints. User management. Skills are going to be understanding of user roles, permissions, and access control. Troubleshooting and support. The skills required are problem solving and technical support knowledge. Documentation and reporting. Excellent proficiency in documentation and reporting too. Here's a summary of what we've covered. So now to conclude, the role of a database administrator is a multi-phased, encompassing a wide range of tasks and responsibilities to ensure the efficient and secure operation of our database system. So this was everything for today's session. Is there any question for me?
Thanks, Victor. No, that was all very clear. Thank you. Obviously, being a data analyst, yeah, working with databases and stuff is
Okay.
not unfamiliar to me. I know it well. So yeah, that was all really good. Though. Good to have to like a little refresher and go back over some of those points. So yeah, that was all really good. Thank you.
Okay. Okay. Thank you for that, Johnny. And if there's no any other question, I will end this session. I'll see you tomorrow.
All right, see you tomorrow. Take care,
Okay,
Victor.
you too. Bye.
Bye.